Hello, everyone. This is Carlos Ponce at Nearsoft. Somewhere in Mexico, I'm about to take my little Easter break, and we are hosting today's Dojo Live session. And for that purpose, we also have my fellow teammate Tulio Siragusa in LA. Hi, Tulio.
Hey everyone,
As
welcome
ever,
to the show.
thank you so much for being here, Tulio. And also, we have Clement Ronzon, my fellow teammate in our Hermosillo office. How
Hi
you
there.
doing?
Fine,
It's a
thank you.
pleasure. It's a pleasure to have you here, Clement. It's been a long time. Appreciate that your willingness to join us in such a short notice. Okay.
Yep.
And last but not least, I would like to introduce our guest today. We are going to be having a conversation with Mr. Robert Reeve. He is the managing director of TWIND Power in Canada, and we're going to be talking about IoT and IOTAs, also what it's known as IOTAs. So he'll tell us more about that. He's the expert. So without further ado, I'd like to introduce our guest, Robert Reeve. Robert, welcome to the show, and it's a pleasure and an honor to have you here on this craziness called Dojo Live. Welcome to the show.
Thanks, Carlos. Thanks.
Absolutely. Okay, Robert. So I would like to start off by asking you just a couple of things. Tell us a little bit about you, and tell us about your company. Where do your background, pretty much for the audience, and then the company, and then we'll move on to today's chosen topic. That should be interesting.
All
Thank
right.
you.
Well, quickly, I started off as a programmer in the very early PC world of DBase and DBase 2, DBase 3, and Clipper compilers, working on what we call today ERP systems and CRM systems. And at night, I've spent some time integrating networks in the customer's site and then installing our software on their sites. A lot of the shops we dealt with were small suppliers to the auto industry, or they were in the distribution business, moving boxes. So that's how I got my start. I consider myself an old Fortran warrior that turned into a Pascal warrior that turned into a Java warrior, and now I live and breathe Python in the test world. So that's my programming background. The journey I've taken has really been out of software into networking via Cisco. I was one of Cisco's first guys, and in fact, their first field sales guy back in '89. So for English-speaking Canada, there was one other gentleman that was in French-speaking Canada, a gentleman by the name of Michel Boisseria, and the two of us actually opened up Cisco in Canada. And this was pre-IPO, before the company was taken public. And I worked there for 5 years, learned quite a bit about routing, and evolved and went into high-speed networking with Four Systems out of Pittsburgh. Did that for 5 years, spent some time in Europe. And before all of that, though, I can say that I spent some time with Rockwell Allen Bradley working on integrating old HP systems and DEC systems into factory floor networking, where we picked up the data from PLCs and what they call SLICs or SLCs in the Allen Bradley Rockwell world. And much of that had to do with picking up SCADA information from either job shop environments or continuous process environments. So I've got a pretty strong background in that area. And hence, that's why I'm doing what I'm doing today. It's come full circle. And that over the years, in the last 4 or 5 years, I've moved away from just working with high-tech companies and been more focused on building new off-grid energy stations. And now we've finally come to market with those at TWIND Power. So that's the short version of a very long journey.
You brought me back quite a bit of time in that journey. I started my career in 1989,
right,
at MCI, working on nights on a network operations center. So
okay, yep. Yeah, MCI had a little bit of time in Canada. They bought up UUNet, and some of the guys I know in Toronto worked for MCI before it all blew up. But yeah, it's I did spend some time, just geographically speaking. A lot of the time I spent early in my career was in the Toronto area. And then I moved to Germany in the 90s. I at the time was married to a German person, and we had a couple of children together. We lived in Germany for a while, and then we came back to Canada. And it was then when I started a company called PlateSpin, which eventually was sold to Novell for a fair amount of money for virtual machine provisioning. So I have a couple of patents in the virtual machine provisioning space, and also in some new high capacity factor wind turbines that have just recently hit the market. So
well, it's great to have you as a guest. Love to hear about what you're doing now, your company now. How did that come about? What are you guys are doing? What's unique? If you could tell us a little bit about that.
Well, yeah, the Twin Powers is the brand or marketing label of that we use at Harvester. Harvester is my company, where I've taken some investment money from 8 different angels around the world, many of them whom I worked with in the past in the high tech space. And we finally have licensed our technology in the last couple of years to one company that's making clean power trailers out of Toronto, a company called Mobismart. And just recently we licensed into a much different type of wind turbine technology, what they call an acceleration tower, with a company called V3 Wind in Dallas. So we've had some good fortune in getting our intellectual property licensed, and I've been the sole support person in terms of doing the CFD simulation design work and the finite element analysis design work. And I've also built the prototype in the shop for Mobismart. So I have a background I really didn't talk about earlier, but in high school I took all my shops. So whether it was metal shop or whatever, right, electrical, etc. So I took both streams in high school, both the technical streams and the academic stream.
All right. So what you're saying is, anyone who's in high school watching this and wondering, what the heck am I going to do with this shop experience? It might actually come in handy someday.
Yeah, today the shop world is changing, and 3D printing rules the roost in a lot of that space. And that was one of the things we actually used in building the Mobismart system. Among that, we also used laser cutters and some very interesting molding techniques. And we used some old-fashioned aircraft techniques in terms of building the first rotors in a prototype sense, just to make sure it all hung together in a geometric way. So, yes, my recommendation to anybody is that take a look at the shops first before you do anything, because having that background is invaluable. Everything revolves around the shops and building stuff. So if you're building information systems in the world, the Main Street world, you really need to understand how manufacturing works and how distribution works, etc. Before you can intelligently write anything in the software world that helps those people get their job done.
Well, we're also in the embedded world now, right? Software and hardware.
Well, yeah, the embedded world is, for me, some people thought that SCADA was dead a long time ago, but it's even more important now as it ties itself into these things called distributed public ledgers. And at IOTA, which is a German foundation, it's a very interesting company because they don't have the requirement for mining, yet they do use proof of work, where any net new transaction that comes into the network has to first approve 2 previous transactions to be attached to the distributed ledger. And means it's very fast, and the scalability is linear. So it doesn't have the problems of this von Neumann model that the blockchain folks use in Bitcoin and Ethereum, which is sequential and slow, and it'll never scale. And they can do all the database sharding and side chains they want, but it's never going to work properly in terms of scaling for microtransactions in the world of IoT, where you have billions of devices out there today. Everybody talks about, oh, there's going to be billions of devices connected to the network. I said, well, they're already connected. They just use all these proprietary gateways that are sold to you at great expense by vendors like Schneider. You're from France, you know who Schneider is, and Rockwell, and all these companies that charge an arm and a leg for their SCADA systems and their factory floor systems. That world is about to be, and is being put on its back heels as the bigger companies in Europe, especially in France and Germany and the Nordics, are moving to IOTA for all their proof of concepts. They're winning all the proof of concepts. So it's very interesting what's going on in the so-called IoT fog and mist segments of the market. In this shift to using distributed ledgers, both in a private sense with Hyperledger from IBM, I shouldn't say from IBM, but IBM promotes it a lot, and also with IOTA in the public ledger sense.
Hey, Carlos, remind us what the topic of choice was today, if you don't mind.
I was going to ask you about that. I didn't want to step into the conversation because it was getting too way too exciting.
It's fine to remind ourselves and the guests.
Absolutely. Okay. Well, Robert, tell us a little bit about why you chose this particular topic. And correct me if I'm wrong, but you told us that you were going to be speaking about integrating SCADA IoT applications into IOTA's scalable distributed public ledger, right?
Yeah, that's correct.
Okay, so tell us, why did you choose this particular topic, Robert?
Well, it's as I alluded to earlier before it came online on air, the thing about distributed public ledgers that people don't really get right at the moment is that they replace a lot of accountants and lawyers, and they can be trusted in the sense that it's machine-to-machine communications. So there's no need for human interaction when one machine settles with another machine in terms of sending its data and getting a confirmation back, and then posting it to an immutable data store where no one can touch it and change it. And that basic premise means that you can do things like settlement between organizations in a very automated way, and even include an administrative layer over top of it as well if you need to, so that it's not totally in the control of the machines. You still have a way to insert yourself in that process. When I say that, that's where a lot of the operational cost savings are. And I'll use the utility business, which I know fairly well, and that there's, if you are selling electricity to the grid with your energy system, you need to settle your receipts with the independent service operator. And what invariably happens is, instead of getting your money after you delivered the energy to the grid, that the end of the month, they sum it all up and says you delivered so much energy to the grid this month, and your receipt looks like this. Well, what happens is you get accountants involved on both sides, and it goes back and forth literally 15, 20, 30, 45 days before you actually get your money. So it slows down the velocity of money, and that because that transaction takes so long because people don't believe the data. They have to check the data. And it's because the data is managed by people. So it's the power company with their creative accountants sending their version of what they thought they produced to the independent service operator. And then there's the independent service operator's accountants going, well, we're not so sure we believe that. And as a result, the flow of money, the velocity of money between the two parties slows dramatically. And that can really hurt your working capital position if you're a small independent power producer. because of the shenanigans that goes on between accounting departments. So distributed public ledger solves that problem.
How big of a problem is that? And how
it's universally across the world the biggest problem in the power industry.
Okay, so why wouldn't anyone want to adopt this? What's the challenge with adoption? Are you seeing some pushback, and why?
Well, the distributed public ledgers are new in the sense of using them for not just a store of value, but also for transactions. And the early blockchain versions of these things, Bitcoin being the genesis of everything with their blockchain, and then Ethereum, which has come on and added smart contracts, and some others that have jumped into it, like Tron and others. NEM is another one that I think about. The problem with them, this sequential blockchain world, is the transactions per second, and it can take minutes, hours, days, even weeks to settle a transaction, depending on the nature of the transaction and how that blockchain system is reaching consensus. Is it a proof of work system? Okay, well then the miners get to work and away you go, and your settlement times might vary from a couple of minutes to hours. Or you may use a proof of share model where the transactions will happen fast, like EOS, but it's people who are in control of it. And you're at the mercy of whoever's got the most amount of money in terms of their proof of share as to those people running that proof of share consensus to actually create the rewards and allow that transaction to be attached to the distributed public ledger. So the world is evolving, and it's only recently that IOTA has been able to prove that their technology scales. They have been using a centralized coordinator, which worries a lot of people because it's a single point of failure. And they just recently announced their test network without those types of capabilities in terms of centralized control. So the world is changing to the point where now the distributed public ledgers are really close to being viable for things like the power industry. Maybe in a couple of years we'll actually be there. I think it's going to be 2 or 3 years before people will commit to an automatic settlement mechanism where there is no delay in settling the receipts with, as far as the independent service operator is concerned, paying the independent power producer for the energy produced. So it's coming.
Well, it sounds like you're solving a pretty big problem that also impacts the consumers. I'm interested in getting some questions. I think there's a few from the audience and
Sure.
Co-hosts coming on. Please unmute yourself. I did mute you before because it was playing a little trick with the screen. But please go ahead and ask some questions.
Yeah, I have a question regarding IoT. Is it how you pronounce it?
IOTA, yeah.
IoT. So I've read about it's a protocol, right?
Well, it's multiple protocols actually. There's the currency itself, which behaves just like any other cryptocurrency in the sense that you have a wallet. It is different from many in that all the coins that were ever going to be produced have been produced. So there's no mining required. And you can use the IOTA currency to settle transactions today and transfer money between your wallet and somebody else's wallet in a peer-to-peer sense today. You don't have to go through an exchange. That said, it is on an exchange and is traded on multiple exchanges. So it's very similar in that regard. What differs, IOTA differs from virtually every other cryptocurrency and blockchain play in that it is a linear scalable technology that uses what they call a cyclic graph. Well, if you're a database guy, you know what that is, a DAG. So it's just essentially a tree that goes in one direction. And it's able to support immutable and mutable storage of data. In the IOTA node, the IOTA node communicates with all the other nodes in a distributed fashion, but the approval today of the transactions is still managed by the central coordinator to ensure the safety of the transactions. That's about to be removed just generally. I suspect it will happen this year, and you'll see many more companies adopt them beyond Volkswagen and Bosch and Audi and Fujitsu Germany, etc. There's a lot of big companies working on IOTA today. Most of them are European. And this is not well understood in North America. They think the sun rises and sets out of the Bitcoin's rear end, if you like. And that's just not the case when it comes to IoT, especially in Europe. So I think that the thing that you have to remember, it is a protocol. There's basically 4 sets of protocols that run in the node. And one of them is a peer-to-peer communications protocol, which is free. And there are services that have been built on top of that, like chat services that allow you to chat peer-to-peer anywhere in the world across the IOTA set of nodes in the public distributed blockchain, as some people call it, but distributed public ledger is more correct. And so that means you can literally communicate to anybody around the world using it. Now, there are some companies that have actually built peer-to-peer video conferencing systems over top of IOTA. In Holland, for instance, there are also some companies in Holland and Germany, also in the Nordics, and also in France that have invented some new systems on top of IOTA that make it possible to use bio security systems. So I think particularly in Switzerland, there's one called IMPass, and that's caught on like wildfire. And it makes a lot of sense for biometric access in the data centers, et cetera. But not just that, for many other things. So it's an exciting time right now at IOTA. And I don't work for the IOTA Foundation. I'm just looking to use their nodes in our energy stations and host the nodes in the energy stations and have our SCADA data move from the SCADA controller as an Oracle interface into the distributed blockchain. So we can post our data onto either a private side chain, which we use internally, and where there's a regulatory reporting requirement in the public sense for safety and security, and also with the independent service operators when they want to know how much power is produced, we can also publish the data directly from the energy station with no human intervention to the public blockchain. Or IOTA distributed public ledger, as people will soon find that's the correct term to use for these systems. So it's exciting times, and we use there's a protocol called MAMS, just to answer the protocol question, that allows that peer-to-peer protocol to work between anything. So you can literally add it into an app, a server, a SCADA controller, whatever it is you want, make it a part of an FPGA or ASIC implementation, and away you go. Today, they take their ternary math, which is sometimes called trinary. So forget about binary, zeros and ones. In the IOTA world, everything works in trinary. I'll use that term. That's really ternary is the correct term. But that means you've got +1, 0, and -1. And that also means that when you do calculations, you can store massively larger numbers with much greater precision. But even more importantly, you can save yourself 35 to 65% in terms of power consumption by building a trinary or ternary FPGA or ASIC. Now, today, nobody does that. They have conversion tools that take it from their high-level language, which is called CUPLA, which is a scripting language. And then there's a converter that takes it down to an intermediate language called Abra. And then that Abra language can be sent via Verilog to the FPGA or to the ASIC. And that's currently in process right today. And one of the bigger players doing that is Bosch. if you don't know who Bosch is, Robert Bosch is 300,000 person strong company who's leading the way in terms of IoT access.
I have a question. That something sparked up a question. You were talking about energy consumption or reducing energy consumption.
Yes.
And there's a couple of big players like Google and others. I mean, their energy consumption is massive.
Yes.
What are some of the key target clients that should probably implement this like now, in your opinion?
Well, yes, you have to look at this sector by sector, but I think anybody who's in the utility space knows there's meters all over the place, measuring power in your residences, and so-called smart meters. And there's a cost to operating smart meters, which gets passed on to the ratepayer. And there's definitely an opportunity for those guys who are in the smart meter space to adopt this right away and really improve their own margins, reduce the cost of their equipment, and downstream even see a slight reduction for the people that are paying the power bills, the ratepayers. So there's definitely an opportunity right away in that space for people to wake up there. In the automobile space, Volkswagen and Audi and now BMW are all over this. And they've been working very closely with IOTA for the last 2 years in terms of machine-to-machine transactions, which ties into electric vehicle charging systems. So they're way ahead in that, and they've already deployed systems in Holland with ELAD, one of the power utilities, offering electrical charging stations in Holland, and have demonstrated that you can literally roll up, plug your car in, the machines do all the transactions, you're done, and it all works with the car interface to your mobile phone. And you don't do anything. You just roll up, plug it in. When you're done, and you get going.
Wow.
And the transaction happens. And those types of applications clearly highlight how this is going to impact the everyday person out in the real world, right? So I paid my power bill, I can charge my car really quickly. And I don't have to fart around at the cashier. These things can be out in the middle of nowhere, completely unmanned, and it just works. So
I have to say this chat's turned into a very good educational conversation too. You know, yeah. We're always against time, and
sure.
We're coming up on time, but I do want to open it up if there's any additional questions or pending questions from the audience. I think, Carlos, you had one or two. We're kind of coming up on time, but if there's any questions, just want to open that up, and we'll give it a second.
Well, we have one question from one of our guys, actually internally, but besides Clement. So, but Clement, do you want to go ahead? Do you have anything else for Robert before we go?
No, go ahead.
Well, this question came from Sandra, by the way, one of our marketing team members.
Mm-hmm.
Hold on one second. Slack, here it is. She says, who are your customers, who are your clients, and how are they best served by your offering? So this is more of an open-ended question.
Right.
But,
yeah. So with energy stations, this thing called IPP, which is independent power producer, these are the people that negotiate power purchase agreements with the independent service operator. So now, who is an independent power producer? Well, one of the big ones definitely could be and should be the mobile operators, but today they aren't. As they try to roll out 5G, they're going to have a real problem on their hands because 5G's reach is only 300 meters, and many of their towers are kilometers apart. So it's not just as easy as adding 5G to their existing tower. They won't have any coverage. So in order to get the coverage, they have to have these things spaced 500 meters apart in high density areas to get high speed 5G to work. Now, how are you going to do that? You're going to call your power company and have them hook up every bloody tower that you've got? I don't think so. So this is where the off-grid opportunity to just do a drop-in-place solution, and it just works. Doesn't need to be hooked up to the grid. That's a very big opportunity for us as the market for 5G opens up. So very early days right now, but that's one of the markets we're targeting. The other market we target is remote sites that just have no possibility of getting power from the grid. And today those are run by diesel generators. Because carbon taxes have hit many countries, including Canada, where I'm at, and in many all across Europe, you pay a penalty for running diesel, and that is really starting to have its effect in the marketplace for off-grid power generation. And it's only just recently that the battery systems have been cheap enough to be coupled with solar and wind to make off-grid clean power systems possible. So that's an exciting time, and it's not lithium that's leading the way everybody thinks. It's not Tesla in off-grid. It's actually our companies like Nant Energy in Los Angeles. It's companies like Vision in Columbia Falls, Montana, who make zinc air batteries. And zinc air batteries are already sitting at, with Nant Energy, $100 per kilowatt hour. So when you combine $100 per kilowatt hour with wind and solar, it can compete very easily with diesel. And that's just happened in the last year.
Wow. Well, really appreciate having you. Unfortunately, we're out of time. We're over time. I have one last question we often ask our guests.
Sure.
If you could just keep it short. You obviously taken on a big challenge and a big opportunity. Any words of wisdom, anyone sitting sort of on the fence about wanting to go down this path of starting something new, taking on the challenge of literally changing the world? Any words of wisdom you'd like to share with them?
Yes. If you're founders and you have, there's 2 or 3 or 4 of you starting a new company, you all need to sign what I call a private agreement that says we're all going to vote the same way, so that you can avoid the VCs splitting you apart and taking your company from you. So that's
great advice.
That's a very important thing to get in place if there's more than one of you. If you're a benevolent dictator, then it's not an issue. But normally startups have 2 or 3 people. Make sure you're all on the same page. It's what they call a pooling of interest agreement. So you should always have a pooling of interest agreement between the original founders that says no matter how much we hate each other, we're still going to vote the same to keep the VCs from splitting us.
That's really good words of advice. I think that would have served me well in my first startup.
It would have done the same for my plate spin. But,
well, really appreciate the time you've spent with us. For those watching, you'll be able to go to the landing page. We'll provide links to whatever you want to learn. If they want to connect with you, we'll make sure we have that in place on nearsoft.dojo.com. Great to have you. We look forward to next week. Who's coming up next week as our guest, Carlos?
Next week, we're going to have Mr. Gilad Salamander from eClincher. That's going to be eClincher. That is correct. That's the name of the company. We don't have, unfortunately, we don't have the topic in the tagline yet. But it'll be up there on the website like really soon. So keep an eye on dojo.nearsoft.com, and of course also our social networks. It's all going to be in there, so follow us and keep be on the lookout for our next guest and his chosen topic. That's Gilad Salamander from eClincher, and that's all I have. Tulio,
thank you for joining us, everyone, and have a wonderful rest of your day.
Thank you, and have a great day.
Thank you, Robert, and thank you, Clement.
Thanks. Bye now.
See you next time. Bye bye.
Talk to you then. Bye.
Bye.